Okay, everybody, good afternoon. This is 465. And then today you have section 3.3 and 2.6 due. And then 4.1 and 4.2 are due Wednesday next week, not Friday, Wednesday. Because we have the exam, final exam on Wednesday. Final will start 12 noon and then until 1:50. So 5 minutes before the exam will be available. And then if you can print out, then print out and write down your answers on it. Okay. And then if not, then you don't have to write questions again. Just write your answers on the paper, the home you turn in homeworks, right? So just write the midterm exam. And then after you finish your final exam at 1:50, okay, and then make a PDF file and submit it to the final exam Dropbox until 2:15, until 2:15, no later than 2:15. After 2:15, I don't accept your final exam. And also during the exam, you should join the Zoom and then show me your face and an ID. If you don't have a camera, then you can use a cell phone. I think everybody has a cell phone, right? I don't have, but you have, I believe. So if you don't have the camera, then use your cell phone, okay, to join the meeting, Zoom meeting, and then show me your ID and then face during the exam, okay, all through the exam. I like to proctor. If I can't proctor, then it's a problem. So please do so. Any question about the homework due today? Any question about homework? 3.3 and 2.6, those are due tonight, midnight. Any question? Don't you have any? I like to finish the review today, but if I can't, then I shall do part 2 on Monday. Okay, Monday you can ask me questions, homework questions, of course. So you have time. And also, if you like, you can email me. Okay. If you don't get something, then just email me. I shall get back to you as much as possible. All right, then if you don't have any question about the homework, then I shall do a review. Okay, review number 1. Number 1, this is place 8 chips in the bowl, and 3 have the number 1 on them, and 2 have the number 2, and 3 have the number 3. And suppose each chip has a probability of an ace of being drawn. Now let the random variable x be the number on the chip that is selected, so that the space of x is equal to 1, 2, 3. The set consisting of 1, 2, 3. So 3. We have 8 chips. Okay, 8 chips, and then 3 have number 1. Okay, 2 have number 2, and 3 have number 3. Okay, so these are the ones. 3 chips have 1 on them, and then 2 chips have 2 on them, and 3 chips have 3 on them. This is the one. Then we like to, so random variable x is the number on the chip. This is the one. So this is 1 or 2 or 3. Possible values are 1 or 2 or 3. So this is a set of a space of x. And then we like to have the probability mass function of f. So you should clarify f of 1, f of 2, and then f of 3, right? F of 1 is a probability that x is equal to 1. What is it? What is the probability? 1 occurs 3 out of 8. Okay? 3 out of 8. So this is 3a's. 3 chips have 1. So 3 out of 8. 2 occurs when these two chips are wrong, and that will be 2/8. Of course, you can simplify and 1/4. This is fine, okay. And then 3 out of 8, 3 chips are having 3. So again, this is 3/8. Okay, so these are the probability mass function. The next one is find the mean mu and then variance sigma square. Okay, variance and then mean. Mean mu is the number times the probability. Okay, number times 1 times this, okay? 1 times this, 2 times this one, and then 3 times this one. So we have 1 times 3a's, 3a's, and plus 2 times, we can use 1/4 if you like, and plus 3 times this probability, so 3a's. So this is the one. We have to go back to the definition of the average expectation. So 3a's, 1/2, and then 9a's. Okay? 3a's, 9a's, 12/8. So 3/2, and then 1/2. So gonna be 2. Is that right? I'm not sure. Yeah, 2. But this is the answer. Yeah. Sigma squared, okay, variance. Okay, variance is a expectation of, we can use this formula, expectation of x squared minus mu squared. This is easy. Okay, this is easy. So x squared, so we have 1 squared times 3a's and plus 2 squared times 1/4 and plus 3 squared times 3a's, okay, minus 2 squared. Okay. Variance is the expectation of x squared minus the mean squared. I'm using this formula. And then this is 3, 1, and then 27, 30/8. I don't know. It's 19/4 probably. Okay, minus 4. So 3/4. If I make a mistake, just tell me. Okay. I'm trying not to make a mistake, but sometimes I do. And then last question is find the moment generating function. Moment generating function. This is expectation of e to the tx. Okay. And then this x is 1 or 2 or 3. Okay. And this guy is e to the 1, then if x is 1, then e to the t times f of 1. Okay, f of 1, this is 3a's. 3a's. And plus e to the, this is 2, okay, 2 then 2t, and times the probability that is 1/4. And plus e to the x is equal to 3, okay, 3t, and times the probability 3a's. I accept this. If you don't like this, then you can add 3a's of e to the t and plus 1/4 of e to the 2t and plus 3a's of e to the 3t. Yeah. I accept this, don't worry, or this, either way. Number 2. It is claimed that 60% of the ducks in a particular region have some infection. Suppose 8 ducks are selected as random. Let X be the number of ducks that are infected. Then how is X distributed? What do you think? Each duck is either infected or not. Infected or not. Infected probability is 0.6. We're taking 8 ducks. And then we're talking about the number of ducks infected. So what do you see? What do you think? X is binomial distribution. Binomial, then n is this time. We're taking 8 ducks, so n is equal to 8. And then probability of kind of success. Infected is not the successness, but we can think that way. Okay. So P binomial, and then n is equal to 8, and then P is equal to 0.6. This is a distribution. Okay. And then use the table to find the following probabilities up to 4 decimal digits. The first one is probability that x is greater than or equal to 3. Okay. Then use the table means, as I mentioned, you can use a textbook, right? And then there's a table, binomial distribution table. But there's a problem. There's a problem inside. Binomial distribution. Okay. So this is on the table, but the p values are here, right? 0.05, 0.1, and up to 0.5. And then our case, p is 0.6. Oh my gosh. Okay, we don't have the 0.6. Then what's gonna do? Then we should get y. Okay, consider y. X plus y is 8, total number. So necessary x is equal to 8 minus y. Okay, we're gonna use this y. Okay, then how this y distributed? This is a number. This y is a number of failure. Okay, number of failure. X is a number of success. Now we can see that y is a number of failure. How is this y distributed? This is also binomial distribution, right? And then total number is 8, still 8. And this part is 1 minus this number. If this is p, then this is 1 minus p here. So necessary 0.4, okay, 0.4. This is 1. So take this guy. What is good is we have 0.4, smaller than or equal to 0.5. So we can use the table. That's the point. Okay. The table has the p-value up to 0.5. But 0.6 is outside. So we have to use another random value, that is y, the number of failure. And that is distributed in this way. B of n, same n, but the probability is 1 minus p, so 0.4. Okay, that's my point. So we'd like to show that this guy is so p, x is greater than 3, okay, is equal to, we're gonna use y, okay, y, x is 8 minus y. 8 minus y is greater than 3. Yeah, then what is y? Y is what? Smaller than or equal to 5. Okay. So in terms of y, we can write the original probability. Y is smaller than or equal to 5. And this y is subject to binomial of 8 and then 0.4. Then we can use a table on the textbook. So first n is equal to 8. So we have this, okay, n is equal to 8. 8 is here, 8 is here. And then p is 0.4. 0.4 is here, okay? And then these are the probability less than or equal to this number, less than or equal to 2, less than or equal to 4, and so on, okay, up to 8. So we are talking about less than or equal to 5, okay, less than or equal to 5. So n is 8, 0.4, and then 5. Okay, 5 is here. This number 0.5. 0.9502. Okay, 0.9502. So that's the way it goes. By the table, we can say this is what? Am I okay? 0.9502. Yes, 0.9502. Okay, so this is the one. Okay, so this is a way. Part 2. Part 2. Part 2 is a p. X is equal to 2. Of course, you can use binomial distributions probability mass function to get this, but you can use a table too. That's up to you. Oh yeah, you can use a calculator, scientific calculator. Try not to use graphing calculator. You can use a calculator anyway. And then convert this to y. Okay, what is the y value? Y. X is equal to 2, then y is 6, right? And then if you use the table, then we can do like this. Y is smaller than or equal to 6, minus y is smaller than or equal to 5. Okay, this is the idea. Then leftover is y is equal to 6. Okay. Then you can tell what? Six. 9915. 0.9915. And then less than or equal to 5 is obtained here. 9502. 9502. So will be 0. I don't know, 0.0413. Okay, so this is the answer. Use the table. And then last three, we have the probability of x is smaller than or equal to x. Okay? 6. X is smaller than or equal to 6. Then you can tell this is equal to in terms of y. Okay? Then you can tell y is greater than or equal to 2. Okay? And then luckily we don't have this kind of probability, but consider the complement. Complement is y is greater than or equal to 2. Complement is y is smaller than or equal to 1. Okay? This is a complement, and then it's probability. So we have subtract from 1. Okay? This is the way. And you can see this probability from the table, right? This is equal to 1 minus 0.1064. Okay. And this probability is 0.1064. So gonna be this is 0.8936. So these are the ones. Again, a point is this y is obtained by this way, and then y's distribution is this. Then we can use a table. Okay, that's a point. Right, number 3. Number 3. If I can't finish today, then I should do on Monday. The question is, consider a sequence of independent Bernoulli trials. There is a B of 1 and 1/4. B for the binomial, but n is equal to 1. It's just a Bernoulli trial. And let x be the trial number on which third success is obtained. X is a trial number on which third success is obtained. If first success, then it's going to be a geometric distribution. The third success, this is a negative binomial. Section number is 2.6. That's a negative binomial. So each one is a binomial Bernoulli trial of 1/4. Okay, x is the number. X is a trial number. On which third success is obtained. Then what is the distribution of x? Just a negative binomial. You can write NB, negative binomial, and then R. This 3 is R. Okay? R comes here. That is 3, and then the probability of success is 1/4. Each time 1/4. Success is 1/4. Failure 3/4. So this is a negative binomial, and then R value is 3, and then 1/4 is the probability of success. Okay. Then second question is write the PMF, PMF f of x. What is PMF? The general formula is x minus 1, r minus 1, and then p to the r, 1 minus p to the x minus r. I guess so. Okay. This is the general form. X minus 1 is just x minus 1. And then r minus 1, r is 3, so this is 2. X minus 1 choose 2, and p is 0, 1/4, right? 1/4. P is 1/4. And to the power r. And then 1 minus p is 3/4. 3/4. To the power x minus 3. Okay? And then don't forget the range of x. X is what? This number. We need third success. Okay? So at least 3 trials we need. 3 or 4 or 5 and dot. Okay? Don't forget this guy, right? X is 3 to infinity. Okay, 3, 4, 5 dot. Don't forget this part. Actually, this is indicating the domain of f. Okay, domain of f. Otherwise, the probability mass function is 0. So actually, this is a domain, okay, essential domain. All right. Then next one, find the mean and then variance. There's a formula for this. You don't have to calculate. Formula is R over P. Okay, so R is equal to 3, P is 1/4. Okay, so is equal to 12. 12. Make sense? 12. If you do the trial 12 times, then a third success will appear. Okay. Third success. Oh, you can't see. Sorry. The formula is R over P. This is mu. Okay. And also sigma squared. There's a formula that is given by R times 1 minus P divided by P squared. Okay. This is the formula. R is 3, and then 1 minus P is 3/4, and then P squared, 1/4 squared. So this is the one. Don't make a miscalculation, right? Then gonna be 36, right? So these are the answers. Mu is 12. Sigma squared is 36. This is kind of reasonable. Okay? Reasonable. Okay? 1/4. The probability of success is 1/4. Then out of 4 trials, maybe we have 1 success. Right? 1/4 is a probability of success. So maybe in 4 trials we can have 1 success. We like to have 3 successes. Then how many trials do we need? For 1 trial, we need 4 successes. For 2 trials, 4 times 2, 8. And then 3 successes, then we have 4 times 3, gonna be 12. Very reasonable. Okay. That's the idea. Okay. number 4. Do you have questions so far? All right, number 4. X is subject to the Poisson distribution. And then a parameter is 5. Okay? Parameter is 5. And then find the probability that X is between 2 and 6 using the 3 decimal digit number. Okay. So probability that X is between 2 and then 6. Okay. Use a table. Did I mention this? Using a, yeah, I didn't mention, but use a table. Yeah. And a table is given the probability of this sum. X is smaller than or equal to 6. X is smaller than or equal to something. So write this guy as X is smaller than or equal to 6. And minus X is smaller than or equal to what? 1. Okay, 1. So get this type of inequality, okay? Less than or equal to. And we have a number from the table. There's a Poisson distribution table that is page 499, 490, I'm sorry, 499, 498, 500, okay? And in this case, the parameter is 5, okay? Parameter is 5. So this need not be integer, 4.8, 4.5, 4 point something, those are possible, okay? And then table doesn't have all the values for this one, lambda. So 5 is here, okay? 5 is here. This is a lambda, okay? Lambda is equal to 5, okay? This is a number, lambda is equal to 5 parameter. And then we are talking about 6, okay? 6, x is 6, less than or equal to 6. This is 0.762. 0.762 is the probability that x is more than or equal to 6. It's more than or equal to 6 when the parameter is 5. Look at this number. Okay. So this is 0.762, 0.762, and minus this value is 0.040, 0.040. So you can tell this is 0.722. Okay, so this is the answer. Next one, if x is a Poisson random variable with variance 4, then find the probability that x is greater than 3. X is a Poisson random variable with the variance is 4. Okay. Then what is this number? We have only one parameter, usually written as lambda. Lambda. This lambda is at the same time the mean and also the variance. And in this case, variance is 4. So necessarily this is 4. Okay. Lambda is at the same time mu and a sigma square. Very special distribution. The parameter lambda is at the same time a mean and then variance. This is very odd. This is for the Poisson distribution. So variance is 4, then the number comes here. Okay. And then we like to find the probability of x greater than 3. Okay. We like to consider this probability. How do you? This is same as x is greater than or equal to 4. Okay. X is taking the values non-negative integers, positive integers. Yeah, x is equal to 0, possibly 0, okay, 0, 1, 2. So non-negative integers. So greater than 3 means greater than or equal to 4. And then we don't have this kind of value on the table. We only have less than or equal to. Can you write down using the less than or equal to? X is what? Less than or equal to 3. This is a complement. And then we subtract from 1. Okay, so this is a way. Because this is the only values we can see from the table. Okay, we don't have such a number. So use this type of numbers. Okay. And then this is given by 0.433. Okay. 1 minus 0.433. From the table, we can have this number. So necessarily this is 0.5567. Correct? Yeah, maybe. Yeah, this is the number. This is the answer. All right. Third question. Do you have questions so far? Okay. Number 3. X is subject to the binomial of 500, and then P is 0.01. Yeah, this is a 1. The problem is this 500 is too big. Okay? This is too big, and we like to calculate the probability that X is smaller than or equal to 2. Okay? This is the one we like to calculate, but this 500 is very big, okay? Very big. So we don't like to use the binomial distribution. But we can approximate this by Poisson distribution. Okay? Poisson. This is the idea. The Poisson of this number. Okay? This number is 500 times this number, 0.01. This is n, this is p, then here comes np. Okay? np is coming here. N times p. What is n times p? 5, do you see? Yeah, 5 will come here. The binomial distribution of n and p, okay, will be very close to Poisson distribution of np. So this is 5. This is 5. Then we can use the table. So this is okay. Then I shall use the random variable y. Okay, y. X is subject to binomial, and then y is subject to Poisson distribution. And these two distributions are close, approximately equal. So we can approximate this probability by the probability that y is smaller than or equal to 2. Okay? This is y. Y is subject to this guy. X is subject to this guy. There are two probabilities. These two probabilities are approximately equal. Okay? This is the idea. And then this one can be taken from the table, of course. Okay. And then if you do so, then this is equal to 0.125. Okay? 125. From the chart, from the table, we can see this. Yeah. That's the idea. Once again, the binomial of NP is very close to Poisson of n times p. Okay? When this is very large, okay, very large, and then this should be close to anything. Could be anything. Anything. Ideally, no, there's no ideal thing. Yeah. Anyway, we have to multiply. When this n is very large, okay, that's a kind of condition. Okay, number 4 is done. Number 5. This is 3.1. Continuous random variables. Let a random variable x be subject to a uniform distribution. X is subject to the uniform distribution of 3, 5. Yeah, 3, 5. Then find the mean, mu, and variance sigma. Of course, there's a formula, and then I just use the formula. Okay, this distribution is like this 3 to 5. Okay? 3 to 5. This is the value. What is the height here? Can you tell me? This is 2. So this must be 1/2. Okay. Because the area here must be 1. Okay, this area must be 1. That's the reason. So this is 2, so height must be 1/2. 1/2 is y body here. You can take this is open, and this is closed. Yeah, either way, it doesn't matter actually. Okay. So this is a probability density function f of x. Okay. 0, 0, and then 1/2 between 3 and 5. Okay. The formula is if this is u of a to b, u of a to b, mean is the midpoint of this interval. So gonna be a plus b over 2. So 3 plus 5 over 2 will be 4. Okay. Sigma squared, there's a formula. This is b minus a squared over 12. This is the formula. So 5 minus 3 squared, okay, over 12. So will be 4, so 1/3. Okay, that's the answer. If you know the formula, then it's quick, very quick. Part 2, x is subject to the uniform distribution of 1, 4, 1, 4. Then find the moment generating function and then probability density function of f. Then what is the moment generating function? And then a probability density function f of x. Okay. So what does it? And again, we have the formula. Okay. M of t is equal to, the formula is, remember the formula? That is e to the, okay, u of ab. Okay. If this is the case, this is e to the bt minus e to the at divided by t times b minus a. And this is a 1. And then this is t is not 0. Okay, t is 0, it is always 1. Okay, so this is equal to plug in 4 and then 1 here. So e to the 4t minus e to the t divided by 4 minus 1 is 3. So we have 3t. Okay. And t is not 0. And then this is t is equal to 0. Okay, don't forget to write this one. Okay, t is 0, then it's going to be 1. That's the formula. And then probability density function. Okay, density function is what? Yeah, probability density function f of x. That's gonna be, yeah, similar to this guy. Just replace this 3 by 1, and this is 4. Okay, that's 1. So this is 1, this is 4. So up to 1, it is 0. So you can say 0 up to 1. So x is smaller than or equal to 1. And then up to between 1 and 4, 1 and 4, 1 and 4. I didn't have the equality sign, okay? And then 0 again, 0 again. X is greater than or equal to 4. Okay, what is this body? This length 1 to 4 is 3. Okay, 3, and height is 1/3. Okay? 3 then 1/3, because this region's area must be 1. So 1/3 is the one. Okay, 1/3. So this is a density function. Okay. All right. Then third question. Third question. We have continuous random variable. This is subject to the density function, probability density function that is given by x. X. This is from 0 to square root of 2, and then 0 otherwise. Okay, otherwise. So this is on. The picture is like this. So this is square root of 2, and then of course this is square root of 2. This is a density function. So 0, 0, and then this is 0, okay, 0. So this is an open dot. 0, and then this line segment, and then again 0. Okay, that's a density function. Then find pi sub 0.5. What is pi sub 0.5? We need to remember that one. Right. Okay. Need to remember what pi sub 0.5. Okay. There is a. Can you get the? I'm explaining the meaning of pi sub 0.5. Okay. Can you get the cumulative distribution function? Cumulative distribution function. We have to classify. Up to 0, it is 0, right? Up to 0, it is 0. When x is here, okay, x is here, then we have the region's area. Okay, this region's area. X is a negative or 0, 0. X is between 0 and square root of 2. It's going to be this region's area. This region's area is what? This is x. This is x too. X times 1/2. Do you see this is 1/2 x squared? Actually, this x is integrated from 0 to x. This function is integrated from 0 to x. That's a function here. Okay, this is between 0 and square root of 2. And then after that, it is 1. X is greater than or equal to square root of 2. This is 1. Okay. So this is a cumulative distribution function. And then draw a graph. It's not so bad. This is 1. All the time, the cumulative distribution function's graph is between y is equal to 0 and then y is equal to 1. 0 up to 0. So we have a graph like this. And then this is square root of 2. Okay, square root of 2. It's going to be 1/2 of x squared. So we'll be here. And then between this and this, it's a part of the parabola like this. Okay, part of the parabola will go like this. Now after that, it is 1. Okay, 1. And then 0 up to this, and then this is a curve. And after that, it is 1. Okay. And the pi sub 0.5. Okay? 0.5 is here. 0.5 is here. And then draw a line, y is equal to 0.5. Then there must be an intersection here, right? And then this point is your pi sub 0.5. Okay? That's the meaning of this. If this is replaced by any p, if p is here, then we draw a line. There may be an intersection here, and then this x coordinate is your pi sub p. Okay, that's the meaning of this. So what pi sub 0.5 is the point that the cumulative distribution function is taking the value 0.5. So this is the equation. And for pi sub 0.5 is 0.5. This is the value at this point. Okay, so this is the one. Now what? 0.5 is equal to x is replaced by 0.5 sub 0.5, right? 1/2 times pi sub 0.5 squared. Yeah. Can you solve for pi sub 0.5? Yes, of course. 0.5 and this is 0.5 cancel. We have pi sub 0.5 squared is equal to 1. Oh, it's easy. Pi sub 0.5 is 1. Okay. This is the answer. So this x coordinate is 1. Okay, this is what we have figured out. At 1, it is 0.5. This is 1.4 something, right? So this is a picture. Okay, number 5 is done. Do we have time? Yeah, 24 minutes. Okay, number 6. Okay, number 6. Number 6, a random variable x have a probability density function that is given by 1 divided by 2 factorial and then 2 to the 3 and then x squared times e to the minus x over 2, and then this is for x is positive, so otherwise that is 0. Okay, only this is shown, then we understand that otherwise the density function is 0. Okay, this is a given thing. Then if you look at this guy, then do you think something? Do you see something? Two factorial is gamma function's value at 3. Okay, we know that gamma of alpha is equal to alpha minus 1 factorial. Alpha is a integer. Gamma function's value at alpha is alpha minus 1 factorial. So 2 factorial is same as gamma of 3. 2 factorial is gamma of 3. And this is as it is, 2 to the 3. I didn't write this is 8. Also, this is 2. So here I write 16 and 8. Very confusing. Okay. And then I'm going to write this x to the 2 as x to the 3 minus 1. And then e to the minus x over 2 as this. Do you see something? Yes, this is a gamma distribution. Okay, gamma distribution. Alpha is alpha and theta, right? Alpha and theta. Alpha is this number, 3. Theta is this guy. Okay? This is theta. This is 2. Alpha minus 1. Alpha. Theta to the alpha. Theta to the alpha is this. Okay? So that's a density function. And then look at this density function. We can tell this is the gamma distribution of 3, 2. Okay. This is the first step. Look at the density function, and then we can tell the distribution. In this case, we have gamma distribution. Gamma distribution has 2 parameters, alpha and theta. Alpha and theta. Alpha comes here. Theta comes here. Okay. Then find a moment generating function of. So the first question is we observe this way. Okay, we observe this way. So necessary to answer the first question, x is subject to the gamma distribution of 3, 2. Okay, this is the answer. Good. Second question, find the moment generating function and specify its domain. Okay. If x is gamma of alpha theta, okay, the general formula is 1 minus theta t, and then negative alpha. Okay, this is a 1. And then t is, this must be positive, so t is smaller than 1 over theta. This is a domain. Okay, so x is now gamma of 3, 2. What do you think? M of t is, we'll just replace the values by the 3 and 2, right? 3 is alpha, theta is 2. So this is 1 minus 2t into the negative 3. And then t is less than 1/2. Okay, don't forget this guy. I'm asking you to specify the domain. The domain is this. T is smaller than 1/2. Okay. The last question, we have the probability that 1.237 smaller than x smaller than 16.81. This is what? And then this is a gamma distribution. And unluckily, we don't have a table for gamma distribution. But this is a special case. Okay? This is a special case. What is a special case? Special case is this guy is 2. Okay? This is a special case. 2. When this is 2, then this is subject to the chi-square distribution. Chi-square of this 3 is 6 over, this 3 is 6 over 2, right? So 6 will come here. I'm sorry. This is 6. Okay, this is 6. Sorry. This is 6. This 6 is coming here. This 3 is 6 over 2. 6 over 2, then this number 6 is coming here. The general formula is, again, general formula is, again, we have a general formula. Gamma distribution of alpha, okay, alpha, and then 2. Then this is same as chi-squared of 2 alpha, okay, 2 alpha. I think 2 alpha, and then that's it. Okay? Or chi-squared of r is, usually r is a degree of freedom. That is a r over 2, and then 2. Okay? This is the formula. So please note these guys. Okay? Maybe this is a 1. You should note. R is the degree of freedom, chi-squared of r, and then that is same as the gamma distribution of r over 2, and then this is always 2. Okay? Otherwise, we can't have. So this is the one. So we have a table for chi-square distribution. We don't have a table for gamma distribution, but a special case of gamma distribution like this, we have a table. So we can use that gamma distribution table, okay? And so this is equal to, okay, this is equal to, of course, x is smaller than 16.81, okay, minus probability that x is smaller than 1.237, okay? And then you can use the table to figure out these numbers. Chi-square distribution is on page 501, I think 501. Okay. This is a chi-square distribution table. Okay, this is a chi-square. And then right now, degree of freedom, R is equal to 6. So we look at this row, okay, this row. Yeah, looks like we have this number 1.237. And also we have a number 16.81, okay, these two bodies. So these bodies are indicating this region's area. So number is given, then less than or equal to this guy. The probability is given in the table. So we have 16.81 is this, and that probability is 0.990. Okay, this is a 9. 0.990 minus 1.237, that is 0.025. Okay, so 0.990 minus 0.025. Okay, that's the way it goes. This is not clear, but yeah, you can see your own textbook, your book, okay, and check that one. So this is equal to 0.990 minus 0.025. Okay, so this is the answer. So you have what? 0.965. Okay, so this is the answer. 96.5% are there. So this is part number 6. We have 14 minutes or so. Okay, I'm gonna do as much as I can. If I can, then I do on Monday. So number 7. This is a normal distribution. Okay, so Z is a standard normal, n of 0, 1. Okay, we have a table for this standard normal. And what is the probability that Z is between negative 0.8 and then 0.35. And then always a picture will help you. Okay, picture will help you. We have a density function. Okay, this is a density function. And then 0. And then negative 0.8 is somewhere here. Somewhere here. I don't know exactly. Negative 0.8. And then 0.35 is somewhere here. And we asked to have the probability or regions area here. This regions area we asked to have. And then we don't have the value negative number. So let's see. Okay. There's a distribution table. Okay. And then in this case, the values are positive. Okay, positive. So starting from 0.0, 0.1, and so on. Only positive numbers are given on the left side of the page. And then other side, okay, other side is given like this. Greater than or equal to this number. And so this portion's area is given. So if 0.0, then from here to here, this is of course 0.5, right? Obviously. So we're going to use these two pages to figure out. And so this probability is equal. I'm sorry, this is equal to, right? This is equal to. This is equal to less than or equal to, okay, probability that x is smaller than or equal to, or no, z, sorry. Z is smaller than or equal to 0.35. This is this portion, okay, this portion. But we don't need this guy. But then what we do is take the 0.8 over here. Then this region's area is equal to this region's area. Do you agree? This region's area is equal to this region's area. So the part here is obtained by this region's area minus this region's area. But this region's area is same as this region's area. So this minus this. So is equal to minus of z is greater than or equal to 0.8. Okay. And then these two guys are given in the table. Okay. So that's the way it goes. Then if you use the table, then it will say C 0.6368. 6368 minus this probability is 0.2119. Okay, please check yourself. And then this is obtained as 0.42249, maybe. Okay, so this is the answer. This is the way it goes. All right. part 2. So already 1 o'clock. So I shall stop right here. Right here means after I finish number 7. Okay, and then I should do number 8 and number 9 next time, Monday. But you should do yourself. Okay? One more time the sample exam, and then also 8 and 9 yourself. So next one, X is subject to normal distribution of 2 and then 16. Okay, then what is the probability that X is between 5 and 7? Okay, so this is what is the question. Then this is not the standard normal, so we have to standardize. Okay, so probability that 5 less than X less than 7, we need to standardize the inside. To standardize, we subtract the mean and divide by its standard deviation. This time 4. Okay? Square root of this is 4. So subtract 2 and divide by 4. That's the idea. So 5 minus 2 divided by 4. X minus 2 divided by 4. And 7 minus 2 divided by 4. Okay? So this is the one. And then again, inequality signs are same. Right? So this is the idea. And then you can tell this is Z. Okay? This is a standardized one. This is Z. Okay. And this is what? 3. So 0.75. You better write in decimal form because the table is given by decimal numbers. Less than Z. Less than, what is this guy? 5. So 1.25. Okay. This is a 1. And then this is equal to probability that Z is smaller than 1.25 minus probability that Z is smaller than 0.75. The equality sign doesn't matter. You can put the equality sign here, but if you don't, then that's okay. That doesn't matter. And then get the numbers. Okay? These are given on the right side page. And then also this is the right side page. So if you look up, then you see that 0.8944 minus 0.7734. So is equal to 0. I don't know, 11210. Okay. This is a number. So use the table. Use the table. Otherwise we can't. And last question today. The moment generating function is given. Moment generating function is given as a exponential function of negative 3t n plus 5t squared. Okay, this is that one given. Then what is this distribution? And then of course this is a normal distribution. And then the general idea is exponential of say mu t plus 1/2 sigma squared t squared. And this is a mu and then sigma squared. Okay, this is a formula. So mu is what? Mu is negative 3, obviously. Okay, what is sigma squared? 1/2 sigma squared is equal to 5. So 5 times 2, that is 10. Okay, so this is the answer. Right, so this is it, okay, for today. Do you have questions? I shall do the 8 and 9 next time, Monday. But I want you to do those two, definitely. Okay. Also, yeah, I'm expecting that you do the sample exam beforehand. Then if this is the second time, then you can understand more. Right, that's my point. If this is the first time, then you have to do the second time yourself. Okay. And then actually, before you see the answers, you should do yourself and then figure out your answer. Okay, that's important. If you do so, then you can understand more. I think. Any question? If you have questions about homework, then you can stay and ask me. If not, then you can leave, and then have a nice day.
Professor, I have a question on the review that you just did for number 4.
Number 4, okay?
Yeah, on when you were answering the first one, why did you go from 2 to 6? 2 to 6, and then when you fixed it, you went from 6 to 1.
Yeah, okay. X is actually 2, 3, 4, 5, 6, right?
Mm-hmm.
And 7. We're talking about this. Then less than 7, less than 6 means this, including everything. And then we need this 2. If you include this 2, then if 2 is here, then what happens? Oh my gosh, 2 is taken. And then we are considering only 3, 4, 5, 6. So you should have 1 here. Okay, 1 is less than or equal to 1, then we can count 2, 3, 4, 5, 6. That's why.
Oh, okay. And then for the second part on that one,
Yeah.
you can't just do the complement right away, like.
Yeah, of course. Yeah. Skip this process. Yeah, and then this is fine. Yes. You can skip this process. Yes. Directly come here. That's okay. All right.
What I'm saying is like it can't just be 1 minus x less or equal to 2.
No, greater than 3 means 3 is not there, right? 3 is not there. So we have to include 3. Okay. X is greater than 3. So 3 is not here. So it's a complement. So we have to take 3 here. If you have 2 only, then 3 is gone and not included. Oh my gosh, right?
Okay.
1, 2, 3, 4. Okay, the greater than 3 means this is open, and then considering this guy. Its complement is this 3 must be contained. 3 is contained and going to the left. Okay, that's the idea. So 3 must be contained.
Oh, okay, okay.
Yeah.
I get you. Thank you.
All right. Any other question?
I have a question.
Yeah.
On the very last thing that we did, number 7, part 3.
Yeah, part 3, yes.
It's going to be like, yeah, so 5 square over 2. So it wouldn't be like 25 over 2?
No. Compare these two. Okay. They are equal. 5 is equal to sigma square over 2. And solve for sigma square. That's going to be 2 times 5.
Okay.
Okay.
Thank you.
Right.